Hello students, welcome to the GATE Academy.
The Buddy Boss app for LearnDash is almost here. You can soon launch your own LearnDash.
Welcome everyone, welcome to the GATE Academy. Myself Vishab Shukla, and today we are going to discuss about machine design. Okay, every one of you must be knowing this by now that we are bringing subject-wise session, power booster session or GATE score booster sessions, whose objective is to go through the complete subject or do the complete revision of the subject with the help of problems, with the help of numericals. Are we clear about this? Are we clear about this? Whoever will join, please comment in comment box. Please inform in comment box. Okay, so let me tell you about how we have designed these sessions. Hello Pranav, how we have designed this session. This session will be taken in two parts. First part will be comprising of the topics which are basically fluctuating load, and apart from that bearings, and the lastly gear. Okay, so today we will be discussing these three topics only, and after that, good morning Vijay, good morning Kshitij. Okay, so after that what we will see the rest of the topics, whether it is brakes, whether it is clutches, whether it is springs, whether it is joints. Okay, so all the other topics will be taken after this session, which will be taken tomorrow basically. So 2 hours of session will be today, and then 2 hours of session will be tomorrow. And again I'm saying that I know that many of you are already taking the benefit from these types of sessions. Not only for machine design, we have taken these sessions for each and every topic, or for each and every subjects. Okay, whether it is from mechanical, or you are from civil, or you are from electronics. So let's begin from for today. So this is our first question. Just see here. Try to understand this. You don't have to get worried by watching the question. You don't have to get worried by watching the question. Why? Because these questions are made in such a way. These questions are made in such a way that it will appear to you like it belongs to some conventional type questions. Okay, but these are kept knowingly so that you can go through the complete revision of all the concepts with the help of a single question. Okay, these types of question will not be asked in GATE, but some part of this question will definitely be asked in GATE. That is how we have kept the complete whatever questions we are keeping in this session. Okay, so do not get worried regarding the depth of the question. You just have to be patient and have to understand that what are the concepts we are going through or we are revising. Okay, so here the question is: a cantilever beam made of cold drawn steel subjected to a completely reversed load of 1000 Newton as shown. The north sensitivity factor can be taken as 0.85. Determine the diameter D of the beam for the life of 1000 cycle. Determine the diameter D of the beam for the life of 1000 cycle. So we understand that as far as fluctuating load is concerned, just before giving the solution, just be patient and try to go through the revision, whatever I am asking you to say. Okay, so first thing first, that what understanding do we have? What understanding do we have? Just a minute, class. What understanding do we have when we say that fluctuating load? From fluctuating load, the question may be asked. From fluctuating load, the question may be asked. So the points which we should keep in mind while studying the fluctuating load is, first of all, they can ask the question from terminologies. Okay, you should be aware of what sigma maximum is, what sigma minimum is, what stress amplitude is, what do you understand by amplitude ratio, what do you understand by stress ratio, everything. Apart from that, second thing is you should be having the complete idea of stress concentration. you should be having the idea of KT, you should be having the idea of KF, you should be having the idea of notch sensitivity. Okay, we will watch every possible point from here. You should be also be having the idea of finite life problems, which is basically SN curve. Okay, SN curve is dedicated to the type of load when the loading is completely reverse type, and how the number of cycles and corresponding to that the maximum strength or endurance strength is coming out after performing experiments that we see from SN curve. Okay, after that what we see the designing for the infinite life problems. In this part we will see Goodman, Gerber, Soderbergh, modified Goodman, everything like that. Okay, so we should keep in mind that these 4 points are only points which from where the questions can be asked, so we should prepare accordingly only. Okay, we should be having the complete idea of terminologies, we should be having the complete idea of stress concentration factor, we should be having complete idea of SN curve and Goodman, Gerber, Soderbergh, etc. Okay, so let's begin from here. And let's see that what in this question what they have asked. If you are going to do it by yourself, then if you want to keep it in short, okay, if I will say that how much time, as far as if you're going to take some lectures also, then it will take around 25 hours if you're going with lectures. Okay, if you will go by yourself, then it will take more than that. But if you are going after watching, even after watching some of the videos which are already present on the channel, okay, then that could help you to finish your subject within 35 to 40 hours, okay, if you are going to do it by yourself. You can also take the help from these type of power sessions that can reduce your time. 40 hours can be assumed to be taken, to be required for getting Tanmay. Okay, so here just see here a cantilever beam made of cold drawn steel is subjected to completely reverse load of 1000 Newton as shown. The notch sensitivity factor can be taken as 0.85. Determine the diameter d of the beam for the life of 1000 cycle. Data provided is for the given condition. Okay, Ka, Kb, Kc and Kt is this much. SUT is provided, Se dash is provided. SE is basically endurance limit of standard specimen. So we should understand that what the endurance strength means, what the endurance limit means. Endurance limit or endurance strength is defined corresponding to completely reverse loading. First thing, endurance limit is defined corresponding to infinite life, which is 10 raised power 6 cycles if we are talking about steel. But whether that endurance limit is material property or not. So as far as endurance limit is concerned, endurance limit is not a material property. Why? Because endurance limit do depends upon the dimension of the body, do depends upon the surface finish of the body, do depends upon the place where we are going to use, or we can say that reliability factor, and also depends upon the stress concentration factor. So if the number of notches will increase, definitely it is going to affect the endurance limit, as it was not doing so in case of SYT or SUT. SYT and SUT were considered as that we have taken the strength in case of static loading. They do not get affected by the number of notches or number of irregularities, but here the number of irregularities do affect, and therefore the endurance strength or endurance limit do decrease. So we define modified endurance limit. Try to understand this. what we are going to do here, we are going to find the value of endurance limit, and then we are going to use the SN curve. We are going to use the SN curve. But before that, we have to determine the endurance limit of workpiece of actual condition. Okay, that can be determined with the help of formula Ka, Kb, Kc, Kd into Se. What does Ka means? Ka is the surface finish factor. Ka is the surface finish factor. If you can say that the surface finish is high, then in that case the value of Ka will also be high. But as the surface finish deteriorate, in that case the value of Ka also deteriorate, and you can say that the endurance limit of the body also decreases. Endurance limit of the body also decreases. The amount of stress which it can sustain for 10 raised power 6 number of cycle will also decreases. Okay, because as the surface finish decreases, the number of irregularities, you can say, on surface will come into existence, and therefore the possibility of being failed will increase. So you can say, you can write it here that as surface finish increases, value of Ka increases. Okay, as surface finish increases, value of Ka increases, or you can say as surface roughness increases, the value of surface finish factor decreases. After that, Kb is the size factor. From here, question was directly came into the exam. Question was directly kept into the exam. Just see here. Kb is what? Kb is your size factor. Kb is your size factor. What size factor suggests that, say for example, if the dimension increases, if the dimension of the body increases, then in that case the value of Kb will decrease. Then in that case the value of Kb will decrease. Why? Because as the size increases, the number of notches increases, and as the number of notches increases, the probability of being failed also increases. From there you can say that how this was asked directly in 2019. Okay, if the size of the product is increased, then endurance limit is affected as. So you should be having this idea also. Now after that, Kc is reliability factor. Here also, if reliability increases, or you say that you want to increase the reliability, if in case you want to increase the reliability of the same product, then in that case you have to keep the value of Kc as low as possible. You have to keep the value of Kc as low as possible. Corresponding to that, Se dash will decrease. Okay, and you will say that okay, now this is more reliable, the product is more reliable given that other conditions are remain same. Now after that, Kd is equal to 1 by Kf. Kd is equal to 1 by Kf. Kd is not equal to 1 by Kt. Kd is equal to 1 by Kf. Kd is the modifying factor which keep the eye on the stress concentration effect. Okay, different material shows different uh, different properties corresponding to the stress concentration factor. Every material do not show the same effect on having the same amount of stress concentration. You can say that, say for example, if here is a plate, having hole in it. Okay, having hole in it, the dimension is provided, the dimension of the width of the plate is provided, the dia of the hole is provided. Then in that case you can calculate the value of Kt. Kt is theoretical stress concentration factor, that we all know. But corresponding to different material, every material will show different increase in stress, and therefore we have to define Kf for them. But how to determine the value of Kf? From Kt? For that we define notch sensitivity factor. Okay, so there we get the value of Q, which is notch sensitivity, which is equal to Kf minus 1 upon Kt minus 1. These are the formulas which you should keep in mind, which you should be having the idea of. So Kf, you can say that Kf is nothing but equal to 1 plus Q into Kt minus 1. 1 plus Q into Kt minus 1. If you are going to use this, if you're going to use this in this equation, you know the value of non-sensitivity factor to be 0.85, non-sensitivity factor to be 0.85. So if you're going to put it here, you will say that 1 plus 0.85 into KT. Value of KT is provided 1.35. If anyone will have any type of doubt, they can ask it from here only. Okay. So Ka is 0.78, 0.78, Kb is 0.85, Kc is 0.897, and Kd we cannot calculate directly. We have to calculate the value of Kf first, and then we can calculate the value of Kd. Okay. From here, because Kf is provided, Kf we can calculate with the help of Q, and Kt is provided. Kt is equal to 1.35. So it is 1.35 minus 1. From here you can say that the value of Kf will be value of Kf will be 1.297. So from here you can say that what will be the value of Kd? Value of Kd will be 0.7, 0.77. Is it correct up till now? You have to determine the value of SE dash, modified endurance limit. Okay, for that you need to know the value of Ka, Kb, Kc, Kd. Ka, Kb, Kc, one way or other they are going to provide you, because these are something which are experimentally founded, and you cannot keep in mind, or you cannot memorize for every condition. They are going to provide you the value of Ka, Kb, Kc or Kd, or they can ask directly that if the surface finish will increase, then whether the value of Ka will increase or decrease. So these relations I have already written it over here. From here you can say that what is the value of SE dash. So SE dash is equal to 0.78 into 0.85 into 0.897 into 0.77 into SE. What is SE? SE is provided to be 270 Newton per mm square, 270 megapascal. Everyone should have this idea that 1 Newton per mm square, 1 Newton per mm square is equal to 10 raised power 6 Pascal, or 1 megapascal. Okay, this I think you people are well aware of these points. So from here you can directly say that what is the value of SE dash? This will be around 123.64. This will be around 123.64 megapascal. Now our objective is to determine the life corresponding to 1000 cycle. Determine the strength corresponding to 1000 cycle. Ultimately we have to determine the value of D. But for that D we have to calculate the value of sigma. Now in this question you should understand that at which point the failure will occur. See here, because this dimension is not provided, so we are considering that this portion is safe portion. So we can say that from point A to point D, as we will move from point A to point D, the moment will keep on changing, and it will keep on increasing, and corresponding to that we can say that at point D we can find that it is the point at which the failure will occur. Two things are there. First thing is that it is the point at which the moment is maximum, and second point is that it is the point at which the cross section is getting changed. So the effect of stress concentration is also found at a place where the sudden change in cross section takes place. Okay, so keeping those things in mind, keeping the thing in mind that the data here the length is not provided, so we cannot determine the value of stress at this point. We can directly go and find the value of stress at point D only. So we have to determine the value of stress at point D, but for that, and after that we have to calculate the value of small d We have to calculate the dimension of this shaft, but we can determine that using SN curve. Using SN curve. SN curve, we are very aware of that. SN curve is basically log curve, log base 10 S and log base 10 N. Log base 10 N. Okay, good, Vijay. After this point, the graph becomes asymptotic. You can say that this is your SN curve, this is your SN curve, and this is the point corresponding to 6. This is the point corresponding to 3. Why? Because 10 raised to power 6, log of 10 raised to power 6, log base 10 of 10 raised to power 6 will become 6, log base 10 of 10 raised to power 3 will become 3. Here the point will denote corresponding to 0.9 SUT, and just a minute class, just a minute. And this will be corresponding to SE, log base 10 SE dash, basically modified endurance limit. What we have to calculate? We have to calculate the diameter D. For that, we need to know the value of sigma, which it can sustain, and that can be calculated with the help of this SN curve. Now here in question they have asked basically about beam for the life of 10,000 cycle. Beam for the life of 10,000 cycle. Just a minute class. Beam for the life of 10,000 cycle. Okay, here it will be 10,000, or else we can directly go for the value. If we are talking about 1,000 cycle, then there we can directly say that okay, we are talking about 0.9 SUT. But here it is not like that. We are talking about 10,000 cycles. So log base 10 of 10 raised to power 4 will become equal to 4. So corresponding to this 4, there must be some point y naught. There must be some point y naught. Now we have to use a simple equation of line. We have to use a simple equation of line. Say this is 0.1, this is 0.2, and this is 0.0. Now we should know that x1 is equal to how much? 3. Y1 is equal to how much? Log base 10 0.9 SUT. Log base 10 0.9 SUT. In question they have provided that. In question they have provided that SUT is equal to 540 Newton per mm square. So you will say that 0.9 2.686. Y1 is equal to 2.686. Similarly, you can say that x2 is equal to 6, and y2 is equal to how much? Y2 is equal to log base 10 SE dash. Log base 10 SE dash. So this will become equal to log 123.64. Try to keep your value up to in this type of question, in log curve question, you have to keep this value as exact as possible. Say for example, if I am having 645, okay, then you should keep it up to 645. You should keep it up to 3 decimal places number. That will help you to get the exact answer, or else your answer can range from 10 to 15, and it is possible that will not be in the range of range provided by the gate. Okay, so here you can say that the value of x2 is 6 and y2 is 2.09. Similarly, the value of x0 is 4, and y0 we have to calculate. Y0 value, however, the value of y0 will be log s base 10. Log s base 10. This s will be the endurance strength. This s will be the endurance strength. Okay, so here you can go with the formula of simple line equation. The slope of line 1 2 will remain same whether you will see from 1 O or you will see from O2 or you will see from 1 2. Okay, using that only we are saying that y1, or you can say y2 minus y1 upon x2 minus x1 is equal to y0 minus y1 upon x0 minus x1. So y2 is 2.09 minus 2.686 upon x2. x2 means 6 minus 3 is equal to y0, that we have to calculate, minus y1. y1 is 2.686 upon x0 minus x1. x0 is 4 minus 3. So this value will be equal to, please answer, 2.487. Here you will get the value of y0 to be 2.487, but we need to know the value of stress. We need to know the value of stress. So we will say that log s base 10 is equal to 2.487, and taking anti-log on both the sides, we will get the value 307.13. S will become equal to 307.13 megapascal. Okay. Now this is the critical endurance strength corresponding to 10,000 cycle. This is the point. This is the maximum stress corresponding to 10,000 cycle, and the maximum stress can be calculated with the help of this loading condition at point D. This will be at point D. This will be m by I is equal to sigma by y. M by I is equal to sigma by y. Here m will become equal to 1000 into dimension, whatever dimension it is having, 0.15 upon I pi d raised power 4 by 64. We know that we have to take the I about the neutral axis, about the diametral axis, horizontal axis. So this will be pi d raised power 4 by 64 is equal to sigma we have calculated 307.13 megapascal. 307.13 megapascal. Okay, and this will be d by 2. This will be d by 2. Are we getting this? So if you want to keep this 307.13 in meter itself, in this unit itself, then in that case you have to keep the value of L in that the value of 150 as 150. Okay, but if you want to change it, you want the value of diameter to come in meter, then in that case you have to multiply it with 10 to the power 6. Okay, let's see here. Let's calculate. From here you will say that okay, this is 2, this becomes 32, this becomes d cube. From here you will solve that d cube is equal to 1000 into 0.15 into 32 upon pi into 307.13 into 10 to the power 6. Just calculate this value. From here you will get the value. From here you will get the value of dia to be 0.017 meter, 0.017 meter, or else you can say that the value of diameter will be 17 mm. 17 mm. You could have also gone with writing here 150 only, and corresponding to that you don't have to keep anything like 10 to the power 6 in here, and you will get the value of d directly in mm. So that also you can do, but we have first calculated the value in meter, and then we have converted it into mm. Is it clear? Is everyone? Very good, Mahadev. Everyone getting this point, that whenever we talk about fluctuating load, then in that case the fluctuating load deals with the stress cycle. And at which point this stress cycle we are considering this stress cycle at the point which is critically loaded. Here which point is critically loaded? Here point is critically loaded. It is also possible that you can get the case, say for example, this is your bar, and in this one axial load is acting. Okay, and here if I will say that this axial load is varying from plus minus 1000 Newton, okay, from positive 1000 to 1000 minus 1000 Newton, then here you don't have to consider about where the critical point is, because here the stress is assumed to be uniformly distributed. But here you have to go for, in such cases you have to go for finding the critical point, and then corresponding to that you have to see that how your stresses are varying, Clear everyone? Okay, so 2 points we have cleared it from here. First is how the stress concentration effect is changing, or you can say that the value of endurance limit, how to calculate the value of endurance limit for actual workpiece from that of the data which is provided for standard specimen. S is provided for standard specimen, and we are also provided with value of Ka, Kb, Kc and Kd, and how these Ka, Kb, Kc and Kd are acting actually. And apart from that, we have seen that how the SN curve actually acts. Okay, now let's move to the next question. Okay, this is a question. A bar is subjected to the combination of steady load of 50 kilonewton and a fluctuating load between 0 and 100 kilonewton. The character endurance limit for the bar is 150 megapascal. The yield strength of the material is 480 megapascal, and the ultimate strength is 600 megapascal. Bar cross section square is square with a side A. A factor of safety is 2. The value of A according to modified Goodman theory. The value of A according to modified Goodman theory. The value of A according to modified Goodman theory. Just a minute, class. We have seen that, okay, we have discussed about the SN curve and all. Apart from that, now we have to understand that what else are important to us. The other points are important to us is designing for infinite life problems. And when we are saying designing for infinite life problem, then we are saying that we are concerned about Goodman theory, whatever Goodman criterion has given, whatever Soderbergh criterion has given. In previous case also we were having one graph, but in that graph on x-axis we were having log n, and on y-axis we were having log s. Here what we are having, we are having sigma a on y-axis and sigma mean at x-axis. These three are very important. First is Soderbergh, which starts from SE and ends to SYT. Okay, which covers the area, which says that only this area is safe, which says that only this area is safe. This is the most uneconomical, you can say. This is the most uneconomical, but most safest. Now, the second line between SC and SUT is the straight line is Goodman line. This parabolic equation is Gerber parabola. Apart from that, there are few more lines. One is ild line, which basically starts from SYT and also ends to SYT Okay, so this is your ild line or Langer line, also known as Langer line. Apart from that, one more line, you can say that one more curve, basically you can say that between SE and SYT, that is ASME ellipse. This is ASME ellipse. I have already told you that the important one were those three which I have told you in the first case. Okay, Soderbergh, Goodman and Gerber. These three are most important. Apart from that, you should only keep in these terminologies, you should keep in mind. So this is ASME ellipse. Now, the equation for Gerber line, Goodman line, Gerber parabola, Goodman or Soderbergh is given with the help of same concept as we have used in class 11th or in class 12th mathematics, basic mathematics, that x by a plus y by b is equal to 1 is the equation for straight line. The only thing, that same thing we are using here. Here the equation will be sigma a upon SE plus sigma m upon SYT is equal to 1. Sigma a upon SE plus sigma f upon SUT is equal to 1. Sigma a upon SE plus sigma m upon SUT square is equal to 1. These equations are for this first equation is for Soderbergh. Second equation is for Goodman. This is for Gerber parabola. Okay, these things you should keep in mind. Apart from that, there is also possibility that they can give in question, they can provide you the value, or they can ask from you the value of factor of safety, In that case, this equation will change to sigma a by SE plus sigma m by SYT is equal to 1 by FOS. How this is actually happening is, instead of SE, you are now taking the value of SE to be SE by factor of safety. Say for example, if I am saying this is my Soderbergh line. Okay, so if I will say that, okay, now I have introduced the factor of safety of 2. Now I have introduced the factor of safety 2. What does that mean? How does it appear to you? It will appear like this. Earlier the safe reason was this. Now the safe reason is reduced to this much. Okay, SE itself will decrease to SE by 2 and SYT will also decrease to SYT by 2. And now this equation will become equal to SE by FOS upon SYT by FOS is equal to 1. So this can be written as, including the factor of safety also. We can write it here like sigma a upon SE plus sigma m upon SYT is equal to 1 by factor of safety. Keep this, whatever I have told you in mind, that here, if I'm talking about Gerber parabola, then in that case, you cannot directly write sigma A upon SC plus sigma M upon SUT square is equal to 1 by FOS. Here also you have to keep SC to be SC upon FOS and SUT to be SUT upon FOS, and then only you can solve. Corresponding to that, you will not be getting the value of this equation as equal to sigma A by SE plus sigma M by SUT square is equal to 1 by FOS. That will be incorrect. Okay, you have to solve keeping in mind that SE will change to SE by FOS and SUT will change to SUT by FOS. Clear, everyone? Okay, there is also one possibility. So 90% of chances that you will get the question directly from this simple formulas. 9% of chances also that you will be asked about factor of safety and all. But there is also one chance that they will, instead of providing corrected entrance limit, they will provide you entrance limit and they will provide you the value of KF. Okay, they will say that the fatigue stress concentration factor is provided in the question. Then determine the value of factor of safety. Then in that case, apart from using every other data in the given formula, you have to also use KF in this formula. How to use KF? You should understand that as what we actually use in this formula is corrected entrance limit. We use SE dash only. Okay, and SE is what? SE is defined for a specimen. Now in question they have provided that okay, the entrance limit for a specimen is something and the value of KF is this. Then how to include this KF in this with this SE? You know that SE dash is equal to KA, KB, KC, KD into SE, and KF is equal to 1 by KD. So you can say that in order to replace that KD, you can say SE dash becomes equal to SC upon KF. Once again, understand, KA, KB, KC, KD into SE becomes equal to SE dash. Now, because every other data is not provided, so we are not concerned about these datas. We are concerned only about KD. Now, how to get the value of KD? KD is equal to 1 by KF. So we will directly divide the value of SE by KF in order to get the value of SE dash. Actually, we need here modified entrance limit or corrected entrance limit. So this SE will become equal to SE by KF. If they have provided that this SE is not already a corrected entrance limit, it is entrance limit corresponding to a standard specimen. Okay. Are we getting this class? Now, after that, one more concept is there. Regarding to modified Goodman theory. What happens to modified Goodman theory? In modified Goodman theory, we take two lines into consideration. First is Goodman line, and second line is yield line. And we say that if our area is safe, if our design is safe from both Goodman as well as yield line, then we will say that okay, now the designing has done as per the modified Goodman theory. Now this dashed, you can say that combination of two lines is our area of concern. How to calculate the values using this modified Goodman theory? Here you have to calculate, or here you have to basically use both the equation, both SYT corresponding to yield line equation also, and corresponding to Goodman line equation also. So you will write one equation to be sigma A upon SYT plus sigma M upon SYT is equal to 1 by factor of safety. If in case they have provided the factor of safety, this will be your yield line. Okay, and the second will be sigma A upon SE plus sigma M upon SUT is equal to 1 upon factor of safety. Now try to understand understand this point, that say for example, if you are solving these two both the equations and you are getting the value of factor of safety to be 2 from one case and factor of safety to be 5 from another case, factor of safety to be 2 from one case and factor of safety to be 5 from another case, then what you are going to answer, you have to answer the minimum of the two. You have to answer the minimum of the two. Try to understand this. When you're saying the factor of safety is 2 or when you're saying the factor of safety is 5, then you have already determined that, okay, what is the value of sigma A, what is the value of sigma M. Okay, what is the value of sigma A, what is the value of sigma M. Corresponding to that, you have already determined what is the value of area, or you can say dimension. What is the value of dimension, and also what is the value of load. So all these things are already determined, already judged, already finalized. Only thing is that from one part you are getting the value of factor of safety to be 2, and from another part you are getting the value of factor of safety to be 5. Now if as a design engineer you are going to say that, okay, the design whichever I have made is having the factor of safety to be 5, then this is incorrect as far as safety is concerned. Then telling anybody that the design which I have created is having the factor of safety to be 5, then this is unsafe. Why? Because some part of the design has been taken with the help of yield line, and whenever the design is placed on that line, there the factor of safety was only 2. So from safety point of view, you always have to tell the minimum value of factor of safety, whatever value of factor of safety you are getting from these two equations. Say possibly it is also possible that you are getting the value of factor of safety to be same from both the equation, then in that case you have to answer that only. But in case if you are getting one value from one equation and another value from second equation, then in that case you have to tell the minimum value only in order to keep your design safe. First point was that, say for example, instead of factor of safety they have asked about the area, they have asked about the dimension. So you have to tell the maximum area. Again I am saying, from the safety point of view, say for example, from equation 1 you are getting one answer that, okay, the area required for the design is 50 mm square, and from second equation you are getting that area required for the design is, for given factor of safety, for given sigma A, for given sigma M, for given SYT, for given SUT, the value of area required is 70 mm square. Then in that case, how to approach, what we have to tell the answer, what we tell in answer. So in answer we will say that it is 70 mm square area which is required, because when we will take 70 mm square area, then it will also fulfill the requirement of this area 50 mm square, which is required as per, say, yield criteria. Okay, say yield line is saying that I need only 50 mm square area, and another line is saying that I need 70 mm square area. So corresponding to that, you have to take the maximum area in order to keep the design safe. However, for some part of design it will be uneconomical because there only 50 mm square of area was required, but still you are giving the area to be 70 mm square. But as far as safety is concerned, this is the perfect design which you are telling everyone. Are we clear about this point? Class, is it clear that whatever area you are going to get from both the equation, you are going to tell the maximum value. Whatever factor of safety you are going to get, you are going to tell the minimum value in order to keep your design safe. Everyone, is it correct? Okay. So here you have to answer here. Okay, just answer here. Here you are not directly getting the value of, sigma, but here you are getting the value of load. Okay, so we can say that maximum load is P maximum is how much? As far as question is concerned, question is saying that okay, one steady load, or you can say one static load is applied, one static load of 50 kilonewton is applied, and apart from that, you can also say that one fluctuating load is applied. Okay, these two are applied separately. Means you can say that, say for example, one beam is there, one bar is there basically, and here you are applying 50 kilonewton, and apart from that, one more load is applied, which is varying from 0 to 100, So in total, we have to consider, we have to take both of these into our concern, and then decide accordingly that what is the value of sigma maximum and what is the value of sigma minimum. Or you can say right now we are concerned about what is the value of maximum load and minimum load. So the maximum load will become equal to this sigma static plus sigma maximum. Okay, from here you will say that it is equal to 150 kilonewton, and correspondingly we can say that the minimum value at any time at least one axial load of 50 kilonewton will be there. Anytime at least this axial load of 50 kilonewton will be there. Corresponding to this, we can also define mean load and the load amplitude. Mean load and the load amplitude also can be defined here. Okay, so P maximum is equal to 150 kilonewton. P minimum is equal to 50 kilonewton. If I will say that what will be the value of P mean, so it will be 100 kilonewton, and you can say that P amplitude. I'm not writing sigma amplitude, I am writing P amplitude. Okay, so just be aware of it. P amplitude will be equal to 50 kilonewton. Is it clear? Now what we have to do, we have to write both the equation of L line and Goodman line. So this will be the L line will be written as sigma A upon SYT plus sigma mean upon SYT is equal to 1 by factor of safety. Now what is the value of sigma A? Sigma A is equal to P by A square. Or you can say P amplitude by A square into SYT plus sigma mean is P mean by A square into SYT is equal to 1 by factor of safety. Now we know that value of P amplitude is 50. So this is 50,000 upon A square into SYT. SYT is provided in the question. It is 150 megapascal. It is 480 megapascal. P mean is 100,000 upon A square into 480 megapascal is equal to 1 by 2. So on solving this, you will get the value of A square to be, is equal to how much? This will be 50,000 divided by 480 plus 100,000 divided by 480 into 2. From here you will get the value of A square to be 625 mm square. From here you will get the value of A to be 25 mm. The side should be 1 Yield line is saying the side required is of dimension. The side required is of dimension. The side required is of dimension 25 mm. Okay. Now what about the another line? Another line is Goodman line. Goodman line says that sigma A upon S E plus sigma mean upon SUT is equal to 1 by factor of safety, is equal to 1 by factor of safety. So P amplitude is 50,000 upon A square into 150. A square into 150, and sigma mean is 100,000. So this is 100,000 upon A square into how much? Into 600. Into 600. This is equal to 1 by factor of safety, 1 by 2. So again calculating the value of A square from here, calculating the value of A square, and then again A. Calculating the value of A square and then again A from here, you will find what is the value of A from from Goodman. From Goodman, what is the value of A? So A square becomes equal to, from here A square will be equal to 1000 and A will become equal to 31.62. A will become equal to 31.62. Now the question is, if I am going to ask from you that, okay, according to you, what is the area required? According to you, you are design engineer, and I am asking from you that what is the area required? What you will suggest me that what is the area required, or you can say that what is the dimension? What is the dimension of the square required? What is the length of the side for the square required in order to get the design to be safe? In order to get the design to be safe, please tell me whether it will be 31.62 or 25 mm. Whether it will be 31.62 or 25 mm, which is which will be your answer? Mahadeva, Vijay. 31.62, because 31.62 will be safe for both. If you are taking the area to be 31.62, then however it is bit uneconomical, but still it is safe for both. Are we getting this? Everyone, is it clear? Okay, now moving to the next question. Moving to the next question. Question is, determine the amplitude ratio, stress ratio, variable and range for the given cycle. For the given cycle. Okay. Now here the cycle is missing. Just a minute. For this cycle, you have to calculate this is your origin, this is your origin, this is sigma, and this is time. This is sigma and this is time. Okay. And this cycle is varying from plus 20 to minus 60. Plus 20 to minus 60. Okay, now we have to calculate. Now we have to calculate various things: amplitude ratio, stress ratio, variable and range. Plus 22 minus 60 megapascal. Of course. Okay. Now here you should understand that what are the terminologies we should be aware of. The terminologies are sigma minimum. What is sigma minimum? Sigma minimum is the algebraically minimum value. Algebraically minimum value. Just be here. Just we are going to the complete revision. So so just watch here. Sigma minimum is the algebraically minimum value. Say for example, if I am saying that which one is lesser, 20 or 60, then you will answer 20 is the smaller value algebraically. If I will say which one is lesser, 20 or minus 60, then you will answer minus 60 is the smaller value, minimum value, as far as algebraically we are watching the things. Okay, so sigma minimum will be minus 60 megapascal. Similarly, sigma maximum will be 20 megapascal. Sigma mean is how much? Sigma mean is sigma maximum plus sigma minimum by 2. Sigma maximum plus sigma minimum by 2. Clear? What about sigma amplitude? What about sigma amplitude? Sigma amplitude is equal to sigma maximum minus sigma minimum by 2. So if I am saying that what is the sigma mean, then here it will be sigma maximum plus sigma minimum by 2, means 20 minus 60 by 2 means it will be minus 20 megapascal. Minus 20 megapascal. So the mean will lie somewhere over here. Just a second, class. So the mean will lie somewhere over here. Which is at minus 20 megapascal. Now, sigma amplitude is sigma maximum minus sigma minimum by 2, means 20 minus minus 60 by 2 means 80 by 2 means 40 megapascal. So we know that the value of amplitude is 40 megapascal. Okay. Now, after this, try to understand that we should also be having the idea about the terminologies that they are using. Okay, if we don't know what is variable, what is range, then we will not be able to answer what they want to ask. Range is nothing but sigma maximum minus sigma minimum. Range, this is your range. Sigma maximum minus sigma minimum. What is the range? 100 to 50 is the range. So here 20 to minus 60 is the range. So range is sigma maximum minus sigma minimum. Here it will be what? Here it will be 80. Here it will be 80 megapascal. Range is 80 megapascal. What is variable? Variable is same as that of amplitude. The different name of variable is sigma amplitude. Variable is nothing but half of the range. So this will be sigma maximum minus sigma minimum by 2, which is amplitude. So variable is equal to range by 2. Variable is equal to range by 2. Now, apart from that, two more terms are there which we should be aware of. See here. One is stress ratio. Stress ratio is how much? Stress ratio is sigma minimum upon sigma maximum. Let's represent stress ratio from R. Okay. The another term is amplitude ratio. Amplitude ratio is nothing but amplitude upon mean, amplitude upon mean, sigma amplitude upon sigma mean. So here you can say that sigma amplitude is nothing but sigma maximum minus sigma minimum by 2, and sigma mean is sigma maximum plus sigma minimum by 2. Here you can solve it further also, however this much is also enough, and you are going to get the answer from here also. But in order to save time, one more point is there. It is also possible that they can ask the question like that. Okay, so sigma maximum minus sigma minimum by 2 upon sigma maximum plus sigma minimum by 2. Here you can solve it further as cancelling 2 from both numerator and denominator, and then you can write here it to be sigma maximum upon sigma maximum. You have taken sigma maximum from both numerator and denominator. This will become equal to 1 minus sigma minimum upon sigma maximum upon 1 plus sigma minimum by sigma maximum. Everyone, are you getting this? 2 got cancelled already. Sigma max will also get cancelled. So this will become equal to 1 minus r upon 1 plus r. Say if amplitude ratio is defined with a, then in that case a is equal to 1 minus r upon 1 plus r. Everyone, is it fine? These are few terminologies which you should be aware of. Okay. Now let's move to the next question. Okay, the question is, a ball bearing is subjected to the radial force of 2500 Newton and an axial force of 1000 Newton. The dynamic load carrying capacity of the bearing is 7350 Newton. The value of X and Y factor is 0.56 and 1.6 respectively. The shaft rotating at 720 RPM. Calculate the life of the bearing. And they have asked it in hours. How to calculate? We know that load life relationship is something which exists. What is load life relationship? Load life relationship says that as the load increases, the life decreases. However, it is not directly proportional. However, it is not linear, but still the relation do exist that if we are going to increase the load, then in that case, the life of the object will decrease. The thing is, what do you understand by dynamic load carrying capacity? Can anyone tell me how you define dynamic load carrying capacity? What I have told you, that for particular value of n, if I am having one value of, say for particular value of sigma, or for particular value of p, I am having one value of n. As the p will decrease, the n will increase. Okay, life in million is not required. Try to understand, Mahadev, listen here. Life in million is not required. I'm just telling you that in that formula, however, you will get the value in millions only. But just see here, the thing is that here, as the p decreases, the n increases. As the p decreases, the n increases. For a particular value of p, for very small value of p, the n increased to 10 raised power 6, 10 raised power 6 number of cycles, 10 raised power 6 number of cycles. That is 1 million cycles. That is 1 million cycles. Okay, then in that case we say that this p is definitely dynamic load carrying capacity. If p is less than that, if the allowed force is less than that, then the number of cycles which will be performed will be greater than 10 to the power 6. If p is greater than this, then in that case the number of cycles which are performed by the product will be less than this. Okay, this is okay. The overall idea is P and N are inversely proportional. So we can say that P into N raised power C is equal to, N into P raised power K is equal to constant. This can help you to determine anything. Just see here. If you are using some other formula, then that is also correct. If you are using directly C by P to the power N is equal to constant, then that is also correct. There is no issue regarding that. But here it is very generalized thing that N and P are inversely proportional, but they are not linearly inversely proportional. Here one value of K is also there, which is equal to 3, in case of ball bearing, and which is equal to 10 by 3 in case of roller bearing. It is possible to write this n is the number of cycle. It is possible to write this n in number of cycle, in number of hours, in number of days, in million number of cycles. It is possible to write n in any condition. The only thing is, whatever n, say for example, if I'm saying n1 p1 to the power k is equal to n2 p2 to the power k. Okay, so whatever unit I am using here for n1, the same unit I have to use here also for n2. Okay, so basically the dynamic load carrying capacity is denoted by C. So say for example, if I am using n1 to be 1 million revolution and p to be C, then C power k is equal to n2 into p to the power k. From here you will get the value of n2 to be equal to C by p to the power k. C by p to the power k. Here C is what? Here C is your dynamic load carrying capacity. P is your whatever load you are having right now. K is the constant which we have got, okay, which is defined for ball bearing and for roller bearing. That is different thing. N2 you are getting, N2 is the life of the product in million cycle, but here why it is in million cycle? Because we have used n1 in million only. Say for example, if instead of 1 million I have used 10 raised power 6, I have used here 10 raised power 6, so the equation will become 10 raised power 6 into C to the power k upon C by p to the power k is equal to n2. Now n2 will be now n2 will not be in million revolution, n2 will be in number of cycles only. Now n2 will be in number of cycles only. Are you getting this? Depending upon in this formula what is the unit of n1 you are taking, in the same unit n2 will also be there. Is it correct, Mahadeva? Is it correct? Here if I will ask from you then that in this formula what is the value of what is the unit of n2? If I'm getting n2 to be 50,000, if I'm getting n2 to be 50,000, then you are not going to say that this is 50,000 million revolution. This is only 50,000 cycle corresponding to this formula. Why I'm saying like this, that in many cases they can provide you just the number of hours. They can provide you number of hours and they will ask the number of hours corresponding to change in the load, Then in that case, you don't have to convert it into millions and then reconvert it into number of hours. Getting this? You should understand that n1 and n2 should should be in the same unit. That is it. Okay. Now here it is rightly said that the C is equal to basically C is equal to how much? 7,350 Newton. But what is the value of P? P is not purely radial or purely axial. So here in this case we will calculate the value of P equivalent, which is XVRA XVFR plus YFA. This is the formula for determining the equivalent load. Here X and Y are the factors which are multiplied, or you can say the radial factor and axial factor, which are multiplied with the radial force and axial force separately, and V is the race rotation factor. Say for example, if inner race is rotating with respect to the outer race, then in that case V becomes equal to 0, V becomes equal to 1. But in case if outer race is rotating with respect to inner race, then say for example inner race remains constant, inner race do not rotate, inner race is static in nature, and it is outer race which is moving with respect to the inner race, then in that case we will say that V is equal to 1.2. However, they will either provide the value of V over there, or they will not ask you the question in this form. Okay, so here it is in this question they haven't mentioned anywhere regarding V, or anywhere regarding whether inner race is rotating or outer race is rotating. So directly we can consider the V to be 1. The formula will become equal to XFR plus YFA. X is equal to 0.56. FR is the radial force, so this is 25 Henry Newton, and Y is the factor corresponding to axial force, so this is 1.6 into 1000. So P equivalent load can be calculated as 3000. So equivalent load can be considered as 3000 Newton. Equivalent load can be calculated to be 3000 Newton. Now in question they have asked that dynamic load carrying capacity of the bearing is 7350 Newton. So I am directly writing in terms of number of cycles. I am eager to calculate the number of cycles directly only. So I am saying that 10 to the power 6 into 7350 to the power 3. Why 3? Because it is ball bearing, must be equal to n into equivalent load is 3000 to the power 3. Directly we can calculate the number of cycles. 10 to the power 6 into 7350 divided by 3000. So the number of cycles becomes equal to 6002500. Once again, let me check. 10 to the power 6 into 7350 power 3 divided by 3000 power 3. What is the value of n we are getting? What is the value of n we are getting? What is the number of revolutions we are getting? Number of cycles we are getting? Please answer. फॉर्मूला अंकित जायसवाल, फॉर्मूला आई हैव मेंशनड इट, यहाँ पे फॉर्मूला बताया है ना, np टू द पावर k इज इक्वल टू कांस्टेंट यूज कर सकते हो. चलो ठीक है, इसको क्लियरली लिख देता हूं मैं. n into p to the power k यूज कर सकते हैं आप, and here k will become equal to 3 for ball bearing and k will become equal to 10 by 3 for roller bearing. And while determining the value of load, equivalent load, P equivalent, then in that case you can say that this is XVFR plus YFA. Here X is the factor for radial load, corresponding to radial load factor. V is raised rotation factor. V is raised rotation factor. FR is radial load of course. Y is axial load factor. Y is axial load factor. ठीक है, यहां पे you can see here this is the formula in order to determine the value of P equivalent. एक बार ये आ गया, उसके बाद फिर आपको सिर्फ और सिर्फ नंबर ऑफ रिवॉल्यूशन, ये फॉर्मूला डायरेक्टली नहीं लिखा मैंने, ये फॉर्मूला यहीं से आया है. Okay, Vijay is saying the answer to be the number of revolution is just let me confirm it once. One 14706125 14706125. क्लियर है ये? तो ये this is the number of cycles. Now if I want to calculate the number of hours it is going to work, so it is performing how many number of cycles per minute? It is performing 720 number of cycles per minute. 720 number of cycles per minute. So if I'm saying that per hour how many it is performing, we will multiply it by 60. Now this is the amount of cycle it is performing per hour. And if I am saying that how many number of hours it is performing, how many number of hours it is living basically, so this number of hour will become equal to 14706125. Please tell me the final answer. The number of hours 14706125 divided by 720 divided by 60. This will be around 340 hours. 340 hours. So this machine will last for 340 hours. Is it clear, class? Is it clear? Very good, Vijay. Everyone, please make it sure. Please make it confirm. Okay. ठीक है, तो ये these are the two formulas, or you can say that these are the two concepts basically which we have understood. First thing, that with increase in load, the life will decrease. And how it is related? It is related as n into p to the power k is equal to constant. What is the value of dynamic? What do we understand by dynamic load carrying capacity? Then it is the amount of load which one can sustain, corresponding to which one bearing can sustain, corresponding to 10⁶ number of cycles. So if I am saying that dynamic load carrying capacity is 7350, then I am also telling you the number of cycles, which is 10⁶. Or else it was also possible that instead of writing this, the dynamic load carrying capacity of the bearing is 7350 Newton, I would have told you that corresponding to 10⁶ cycle, a bearing is performing taking 7350 Newton of load. Or even without giving any data corresponding to dynamic load carrying capacity, still you will be able to find the answer. If I will say that, say for example, if I will say that corresponding to 10⁵ cycles, the amount of load which one can sustain is 10,000 Newton. Then determine the number of hours it is going to last if such and such is the loading condition. 2500 and 1000 is the loading condition. Every time you do not need to have the data corresponding to dynamic load carrying capacity only. Are you getting this? You just need to have this value, this n1 p1 to the power k is equal to n2 p2 to the power k. Out of that, 3 should be known, 1 should be unknown. That unknown you can find. Okay. Now let's move to the next question. So this is the question. A square general bearing has a shaft diameter of 40 mm. Shaft is rotating at 20 radian. Two sessions only, one today and one tomorrow. अंकित 2 ही सेशन होंगे सर, ठीक है. A square general bearing has a shaft diameter of 40 mm. Shaft is rotating at 20 radian per second and viscosity of lubricant is 20 millipascal second. The clearance is 0.02 mm. The loss of torque due to the viscosity of the lubricant is approximately. Now, इसको करने के दो तरीके हैं. There are two methods to solve the same question. First is using Petrov's equation. Petrov's equation is also very important relation after Soderberg. As far as gate is concerned, Soderberg relation is very, very famous. Okay, that every one of you must be knowing. One more relation is there, which is Petrov's equation. Try to understand this. Say for example, this whole situation can be modeled as. Just try to understand this. This is our journal. This is our shaft. This is our journal and this is our bearing. Okay. Now, in question, they have said that the shaft diameter is 40 mm. And they have told you that the bearing is square general bearing. The bearing is square general bearing. From this, what do you understand? If the bearing is a square general bearing, then what do we understand? What are we getting from square general bearing? What are we understanding from square general bearing? Or we do not understand anything? Or we don't understand anything from square general bearing? There is one data which is provided you with the term square. Very good, Prince. So instead of giving shaft dia and length separately, they have provided you that the bearing is square general bearing, and directly you will get that okay, D is 40, then L should also be 40 mm. Clear? So this is the two data which we have got. Apart from that, what are the data which we are getting? Shaft is rotating at 20 radian per second. And the viscosity of the lubricant is mu is also provided to be 20 millipascal second. 20 millipascal second. Now they have asked about calculate the loss of torque. Now it is because of viscosity. The loss of torque is because of viscosity. But we can also calculate the value of coefficient of friction directly. Here defining coefficient of friction is partially incorrect, but what we are considering is viscosity also have the same effect as that of friction. So we are saying that corresponding to this viscosity, corresponding to these dimensions, corresponding to all these conditions which we are having right now, whether we can get a value of coefficient of friction, and directly from coefficient of friction we can get the value of friction force, and directly from friction force we can calculate the value of loss of torque. So the value of coefficient of friction can be directly determined by the formula 2 pi square into R by C into mu ns by P. For given loading condition, for given clearance, for given radius, for given RPS, we are having this formula coefficient of friction. Okay, so here you will get the value of F to be 2 pi square. The value of R is 20 mm. The clearance is also provided to be 0.02 mm. mu, we know mu is equal to 20 into 10 is power minus 3. 20 into 10 is power minus 3. Ns, here the revolution we need in revolution per second. Here the rotation angular speed we need in revolution per second. Keep in mind the same unit is required in your Sommerfeld number also. Your Sommerfeld number also. Okay, there the formula is Sommerfeld number formula. We will write it over here after few minutes. But right now here the unit of angular velocity will be in rotation per second only. Rotation per second only. Okay. So this is here it is provided in omega is provided in radian per second. So omega is equal to 2 pi n. From here you will be getting the value of ns to be equal to omega by 2 pi. Omega by 2 pi. The value of omega will become equal to, the value of omega will be 20 divided by 2 pi. 20 divided by 2 pi. Now what is the P? P is bearing pressure. P is bearing pressure. Bearing pressure is what? W upon LD. W upon LD. We know that what is L, what is D. Corresponding to that, we can determine the value of bearing pressure. Here the load is not provided. Here the load is not provided. So you will keep it like that only. W upon LD. W upon LD. Just see here. So this will be W into 0.04 square. 0.04 square. From here you will get the value of, coefficient of friction directly. Coefficient of friction directly. Okay. Now what is the friction force corresponding to that? What is the value of friction force corresponding to that? Friction force is equal to mu into n. Mu into n. And say for example, if this is the W, then in order to model the same thing, what we are considering is on surface one block is placed, which is of weight W. Then in that case, what is the amount of friction force which is applied? So here the amount of friction force is mu into n. The value of, F into n, coefficient of friction into n. Okay, so the value of coefficient of friction is, already we got, n is equal to W. So value of friction you can determine, as 2 pi square into 20 upon 0.02 into 20 to the power 10 is power minus 3 into 20 into, just a second class. Let's directly put it over here only. F is equal to friction force is equal to mu into W. From here W will get cancelled and you can calculate the value of friction force directly. The value of friction force will be 2 into pi square into 20 divided by 0.02 into 20 into 10 to the power minus 3 into 20 into 0.04 square divided by 2 divided by. So this is coming to be 2.01. Mahadev, 2.01, not 3.01, 2.01. I think there is some typing mistake. You have got the right value. You have just typed it incorrect over here. So this is 2.01 Newton. Friction force you have directly got. You have directly got the value of friction force. Now it is the amount of torque. You need to know the loss of torque due to the viscosity. So this is equivalent condition that Fr is equal to how much? Friction force is equal to how much? 2.01 Newton. You just need to calculate the value of torque, basically frictional torque which got lost. So here the radius is 0.02, 20 mm. So the value of MT will be, N will be in RPS, revolution per second. Keep in mind, here also and in Sommerfeld number also, the unit of NS will be same only. While determining this basically while deriving this formula, they have kept n in ns. Therefore, ultimately we are getting n in ns only. Are you getting, Ankit? Okay, so from here you can get the value of MT to be R into FR. R into FR. The value of R is 0.02 into FR, 2.01 Newton. So this will be around 0.042 Newton meter. 0.042 Newton meter. Everyone getting this? Everyone getting this? So this is one way. This is one way of getting the answer directly. This is one way of getting the answer directly. The another way is you have to go through the complete derivation. Everyone, are we getting this answer? Loss in torque, how much? Loss in torque due to viscosity is how much? We have directly calculated the value of friction. We have directly calculated the value of friction force directly, and with the help of this friction force, we have calculated the value of loss in torque, or you can say that frictional torque. If you do not remember this formula, if you will not remember this formula, then what will be your approach? Then in that case, you just have to understand now the things will become little more calculative for you. Okay, so here we are assuming that fluid is in between. This is the side view. The upper one was say if this one was a front view, then this is side view. Okay, from side we are watching, and here it is the fluid which is present over here. Here it is the fluid which is present over here. And this is going for the rotation. This is going for rotation like this. Okay, here it was rotating like this in a way. Here it is going for the rotation like this. Okay, now if I will say that, okay, this is the condition, this body is rotating, with respect to this body. So you can say that, okay sir, if you're considering the eccentricity to be 0, that is the axis of both your bearing as well as shaft is same, then in that case we can consider that from bottom it is at a position of radial clearance. And from bottom it will appear like that a body is slipping with respect to a solid surface, which is static in nature, and here in between they are having fluid, and here in between it is having some fluid. Now say if it is moving with velocity v, then in that case what is the amount of friction force? Whole concept of fluid mechanics is going to apply. Whole concept of viscous force, basically whole concept of fluid mechanics is going to apply. You are going to determine the value of shear stress to be tau is equal to mu del u by del y. Tau is equal to mu del u by del y, where mu is nothing but your viscosity, which is 20 millipascal second. 20 into 10 raised power minus 3. Del u is nothing but the radial clearance. Del u is nothing but, sorry, du is the velocity. Du is the velocity. So it will be r into omega. R into omega. And dy is your radial clearance. This is r into omega and this is your radial clearance. From here you can calculate 20 into 10 raised to power minus 3 into r is equal to 0.02, or you can get the value, r and r is having the same dimension, so it will get cancelled. 0.02 into omega. Omega is omega. Now here you have to put the omega in revolution, sorry, angular velocity only, angular velocity itself. Okay, so it is 20 radian per second. 20 radian per second. From here you will get the value to be 400. The tau will become equal to 400 Newton per meter square. Tau will become equal to 400 Newton per meter square. Now, after getting this tau, you can get the value of, now this is the value of tau. This is the value of tau corresponding to the complete circumferential area. Corresponding to the complete circumferential area. What is the area which is available with you? The area is area at which this tau is acting. The area is pi into d into L. Pi 2 pi r into L. This is the complete area at which this amount of tau is acting. So you will say that what is the amount of friction force, or you can say what is the amount of shear force which is acting. What is the amount of shear force which is acting? So it is 400 into pi into d is 40 by 1000. 40 into 40 by 10 to the power 6. So the friction force will become equal to 400 into 40 into 40 into divided by 10 to the power 6. So again you will be getting the same value of friction force, which is equal to 2.01, which is equal to 2.01 Newton class. Are we getting this? So the same result that what we got from here, if you would have remember the formula, the same result we are getting from here also. Just the thing is you have to visualize here a bit more. You have to visualize here a bit more. In early case, you just have to visualize that, okay, what is the value of FR? Once we will get the value of FR, then we will be able to calculate the value of torque. Here you don't have to see the whole area on which the friction or the viscous force is acting. But in second case, you have to watch completely that at which area this viscosity is acting, this viscous force is acting basically. Is it clear, everyone? Class. So you can go by any approach. I will suggest you that only 3 things are important for sliding contact bearing. That those 3 things are this Petrov's equation, which says that, which basically tell you the value of coefficient of friction, which is 2 pi square into r by c into mu ns by P. P is the bearing pressure, that is W upon LD, W upon projected area. Okay. After that, Sommerfeld number is also important, which is mu ns by P into R by C ka square, R by C whole square. And one more is Mackey's investigation, which relates between the thin film and thick film, which tell you basically about bearing modulus and bearing characteristic number. Here also You are getting the value of coefficient of friction. Here they have told that the coefficient of friction basically is changing with mu ns by p, bearing characteristic number like this, mu ns by p like this. Okay, this is some experimental result which they have obtained. This is some experimental result which they have obtained, and corresponding to the point at which the value of this friction was minimum, the value of mu ns by p, the bearing characteristic number, the value of bearing characteristic number at which the coefficient of friction was minimum is said as bearing modulus. Bearing modulus. So our objective should be to work at this point. Our objective should be to work at this point, but actually what happens, that this left portion of this point, or you can say that this is defined as thin film region. Thin film region, and this is defined as thick film region. Thick film region. So we should understand that here the thin film region is not safe. We always have to work in thick film region, or else there will be direct metal to metal contact will take place. So in case if we will work at this point, then we are not taking safety into our criterion. It is possible that we will reach from this point to this point, and once we will reach from this point to this thin film region, then in that case it will be very hazardous for our component. So we usually work at 5 times of this bearing modulus. However, the value of friction do increase, but it is safe to work in thick film region. Good for you, Ankit. There is no issue. Some people do have problem in memorizing things. If you're having that, then it is best to go with the second approach. Okay, so this is 1.25. This is 1.25 mm module. Okay, now in question, just see here. In question they have said a 20 teeth spur pinion of 1.25 mm module and 20-degree pressure angle transmits the power to a 60 teeth gear. The face width is 50 mm and Lewis form factor Y is equal to 0.322. The dynamic factor kV is equal to 1.26. If maximum bending stress experienced by the pinion is 400 megapascal, then calculate the RPM of pinion to transmit the power of 10 kilowatt. At what RPM it is going to transmit the power of 10 kilowatt? It is asking. Okay, try to understand this. What is this dynamic factor? In actual, when we design for gear, then we assume there so many things. Some of the assumptions I'm telling you. This teeth is assumed to be a cantilever beam. This was also an assumption. It is assumed that load is acting only tangentially. And that too, the load is uniformly distributed at the tip of the teeth. This load is uniformly distributed at the tip of the teeth. These all are assumptions. In actual, you would have seen in theory of machine, where if there you have read about gears, then it is the line of action, and line of action changes from moves from basically addendum to dedendum. Then in that case, you cannot say that always the load is acting at the tip of the teeth. But these are the assumptions which we have considered in order to make the safest design, possible. Okay, apart from that, we have also considered that at one time only one teeth is in contact with another teeth. There is no more than one teeth are in contact at the same time. Okay, so we are considering that whatever load is there, it is acting here only. Apart from that, we have also considered that this load is static load. But in actual, this load is not a static load. It is dynamic load. And that dynamic load factor is taken into consideration with the help of this dynamic factor kV, which is equal to 1.26. So say for example, if you are transmitting the force, if you're transmitting a force, say for example, one force is acting on the tip of the teeth, which is equal to 100 Newton, it will not appear to be 100 Newton. It will appear like kV into 100 Newton, because dynamic condition is more critical. So it will appear to be kV into 100 Newton. Just be aware of something, that kV is something which is going to increase the magnitude of load. Okay, it should be that in actual it is 100 Newton, but it will appear to be 100 into kV. So you have to design corresponding to 100 into kV. Say for example, if kV is less than 1, this was okay when kV was greater than 1. Why? Because in actual, you are transferring 100 Newton, but you have to design corresponding to 125 Newton. Say for example, if kV is less than 1, then in that case, you have to write the new value of Ft, or the load to be 100 by kV. The overall thing is that you have to increase the load so that the designing can be safe. Everyone, are you getting this point? Ft or Wt, whatever. So from here, if you are saying that what is the data which is available to us, so here the spur pinion is 20 teeth. Teeth on the pinion is 20 only. Module is 1.25 mm. Pressure angle is provided 20 degree. Whether we need it or not, we will see it afterward. But right now, the data which are provided, I am just writing it over here. The face width is also provided. This W is provided to be 50 mm. And Lewis form factor is provided to be 0.322. Dynamic factor kV is provided 1.26. If maximum bending stress experienced by the pinion is sigma maximum, they are telling to be 400 megapascal, then calculate the RPM. Of the pinion to transmit the power of 10 kilowatt. Then calculate the RPM of the pinion to transmit the power of 10 kilowatt. RPM we have to calculate, and the power which is going to transfer, which you are going to transfer is 10 kilowatt. Okay, so the question is very simple. You should understand that one formula is there. Ft is equal to or KVFT is equal to KVFT is equal to MBY sigma B, MBY sigma. This formula has been achieved. This formula has been achieved keeping in mind that one cantilever beam is there, which is subjected by a load, which is subjected by a point load at the end of the beam. Okay, keeping that only in mind, we have reached up to this formula. So there is nothing to concern about this formula. There is nothing to be afraid of this formula. The only thing is you have to remember it, because you cannot find it over there. You cannot derive it over there. It will take time. Okay, so here you're having the KV is equal to FT. KV into FT is equal to MB by sigma B. I am again telling you that if the value of KV is greater than 1, then this is okay. If the value of KV is less than 1, then in that case you have to divide it from FT. You have to divide it from FT. So here you are putting the value of KV to be 1.26. FT is equal to M. M is 1.25. So this is 1.25 upon 1000. B is the width. Here B is the width. Okay. So this is 50 mm. Y is also given in the question. Y is provided as 0.322. And last is sigma. Sigma maximum is 400 megapascal. 400 megapascal. From here you can calculate the value of FT. This 1000 10 power 6 will get cancelled, and you will get the value of FT to be 1.25 into 50 into 0.322 into 400 divided by 1.26. This is 6388.89. FT becomes equal to 6388.89. Now, if FT is this much, then what is the value of torque? What is the value of torque? How to determine the value of torque? The torque can be determined by Ft into R, the radius of the pinion. Now, how to determine the radius of the pinion? Just a second, class. How to determine the radius of the pinion? This Ft, I am again telling you, this Ft was assumed. The formula in this formula, whatever Ft you are calculating, you are already calculating in it to be basically acting tangentially. So you don't have to you are not supposed to be get concerned about angle of pressure or pressure angle. Okay, directly you are getting the value of Ft only. So Ft is equal to 688.89 Newton. Torque can be calculated as Ft into R. Now R is the radius of the pinion or radius of the gear if it was required, but here the pinion is required, because here we are calculating on pinion only. We are going to calculate the value of omega for pinion only. That's right. Okay, so here we are saying that torque is equal to Ft into R. Ft we know, R we should know. Now module is equal to how much? Module is equal to d by t. So from here you can say that R is equal to 1.25 into 20 into 2. Sorry, divide by 2. This is in mm, so we have to convert it into meter also. So this is 1.25 into 20 divide by 2 divide by 1000. This will be 0.0125. radius will be equal to 0.0125 meter. Everyone, are you getting this radius? Are you getting m is equal to 2r by t, module is equal to d by t, everyone knows. So from here r will be equal to m into r by 2, m into r by 2. But here the value of r we will be getting in mm only. We have to convert it into meter. So we are dividing it by 1000 also. We will get the value of r to be 0.0125 meter. Value of r to be 0.0125 meter. From here you can say that okay, the ft into r becomes equal to 6388.89 into 0.0125. 79.86 Newton meter. Torque we got 79.86 Newton meter. Now in question what they have said? In question they have said calculate the RPM of the pinion to transmit the power of 10,000 watt. 10,000 watt. Now power is equal to how much? Torque into omega. If you are keeping torque to be Newton meter and radian per second, then this will be in watt. So this is 10,000 is equal to torque is how much? Torque is 79.86 into omega. Omega is how much? Omega we have to calculate basically. Okay, so omega will become equal to 10,000 divided by answer, which is 125.21 radian per second. 125.21 radian per second. Now in question they have asked about RPM. Determine the RPM. So RPM and radian are related as 2 pi n by 60 is equal to omega. From here you can say that okay, n will be equal to 125.21 into 60 divided by 2 pi. Good, Pranav? Good. So from here you will get the value to be 125.21 into 60 divided by 2 divided by pi. This will be around 1195. Everyone getting this? In question they have asked that what is the value of omega in RPM? What is the value of omega in RPM? From here you will get 1195 revolution per minute. Say for example, if in question they would have asked that okay, determine in final statement they would have said that determine the value of omega for gear. Instead of pinion they would have said that what is the value of omega for gear. Then what will be the answer? What will be your answer? Just see here, teeth in gear is 60 and teeth in pinion is 20. So what will be your answer? If in question they would have asked that what is the value of omega for gear, then what would have been your answer, class? It will be divided by 3. It will be divided by 3. Everyone should understand that R1 omega 1 is equal to R2 omega 2. This is the relation which should follow in order to keep the things in contact. Yeah. So here it will be 1195 by 3. Here it will be 1195 by 3. Very good. Very good, Ankit. Very good, Vijay. So I hope this session was useful to you. Most of your important topics are covered and most of the important formulas are also covered. In next class, we are going to see about clutches, brakes, spring, joints. Okay, everything is going to cover. Everything which is left for now will be covered tomorrow. Clear, everyone? So thank you everyone. And in case if you are having any suggestion, you are having any request also, you can post it at quality@thegateacademy.com. Please feel free to contact. Okay, thank you.